Hello everyone. My name is Anindyadeep, and I am the technical head of Cord AI. And today I will mainly present the session on the ML in production and mainly the usage of containerization for designing the model life cycles. So I am presenting my screen. Okay, so I hope that this is visible, right? So yeah, okay. So today, the contents or this is how we will actually move forward. We should actually first have to know that why I should care about development. And up next, we will go through a bird's eye view on the model ML life cycles in the production. The two main pictures, which actually represents the life cycles and explains each. And then we will actually go to how the containers actually work. And then finally, we will actually see some real life examples and then move to some like for further resources in order to like how to proceed after that. So, okay, like why I should actually care about development, right? Because at the end of the day, I was like, we all started actually by creating different types of machine learning models. So, how is all of these things actually related to the deployment? So, if we see that then machine learning is not only about creating just the models. Yes, creating models and innovating through the whole life cycle is considered to be very important, but it's not the sole important thing. We have also have to present and meet the customer requirements through those solutions. And so, for example, suppose I have created a very large models like ChatGPT, which is a large language model, which is like serving a lot of user needs in today's state, and it's becoming one of the most popular. But suppose if I have suppose a machine which is actually not which is having suppose 2 GB of RAMs or something, which is not actually capable of running ChatGPT's like very large machine learning models, then it is of no use, right? So at the end, we have to actually have a very clear understanding. It's that it's not only about creating the models, but it's also like serving the models, having a whole end-to-end pipeline for actually getting the stream of data, pre-processing it, verifying everything, and also at the same time having a very good inference so in a very less latency, and also by providing a high throughput and at the same time that is serving the users and the customer needs. And if you see, there is actually from a source, which is actually taken from the Practitioner's Guides to MLOps by Google Research, we can see actually that only 1 out of 2 organizations actually can only serve the customer requirements, and very less organizations are there which are actually able to deploy their innovations to productions, right? So from the stats only we can see that, and the other surveys, that deployment and the ops or the operations parts in the machine learning lifecycle is very, very important. Moving forward, so this is the bird's eye view for the machine learning in prod. And if you see, then the most of the time that we actually spend is this part, which is the ML code. But there is like a huge sea of other things which are also very, very much important. And a lot of time gets actually spent by actually configuring and creating all of these stuff. Now, there are a lot of services like AWS, Microsoft Azure, and Google Cloud that does and that actually automates and provides services for all of these. But if you want to create some serverless applications, like for example, for monitoring, you are using maybe weights and biases or the other any other services, and for each and every like the phases, you are using some different sort of services for maybe some more customizability. So in that case, a lot the organization actually spends a lot of time, for example, in creating and maintaining all of those like cycles. Now today I will not actually go very much deep dive into all of those because that has been saved for the next session by Nikunj in particularly in MLOps. But other than that, it's if you take a very glimpse of everything, then it's something that the so this is a phase where we actually suppose configure a lot of stuffs, right? Like for example, which which of the services we will be used for example, the data ingestion, for which services we will use for the data streaming, for what we will use for storing the data, what databases should be used, and each of the configurations are stored in one places. Next, we actually collect the data that has been done through the data engineering practices. Another part is the feature extraction. This is actually very much important when we are actually going for that is the inference, and which is the real-time inference, and it actually speeds up the process. For more details, we can check out either the web or it's actually saved on the next session. Next, a lot of part is actually very much in spent for the data verifications, security. The other parts goes for the serving infrastructure, which means I will be having a server that can actually provide very fast inference from the ML models. Some analysis tools and monitoring is actually used to see that, for example, after deploying the ML model, we have to actually have a very good idea, and we actually have to monitor that our machine learning model has been actually is performing very well out of the training data, which is the real world data, which is sometimes out of the distributions or anything. So it is very much important to see how our model is performing and do accordingly. So this is so now if we go, then this is the you can think that this is the MLOps life cycle, and it is very simple. Not it's simple in a smaller glimpse, but a huge time goes in developing each and every phases as well as maintaining it. So if we see, then the first step is actually producing a very robust machine learning models. So now let's just jump into the whiteboard and like let's just like hear a story or something. So the very first thing is like we use, I guess this is you can see from the whiteboard, I guess. So we every general ML modeling or the it starts from a business problem, right? Like we see in the real world that there is some sort of a problem. We figure out that problem and try to convert that problem to some sort of an that is a machine learning problem. And every experimentation starts from our favorite Jupyter notebook. And there we actually starts by developing some sort of analysis. We use model feature extractions, and then we try to build some models and also build on the top of it and reiterate and do a lot of stuff. So we are already familiar with this. And this is the very first, that is the step in the whole life cycle. And then, so this is the first step, which is the experimentation. Next, what we do is like then our once suppose we also have to actually automate this sort of process where our model building process has also been automated, where once the model has been built and it's also been trained, we have to make ensure that the training is not a one-time thing. We also have to actually train the model whenever we will be having that need. For example, suppose I have this version, suppose 0.0.1 of this model, and I have produced this model and actually deployed it for the inference, for the real-time inference. And suppose my model has been performing very well for some time, but now we can see that there is a very much decrease in performance. And this is done during the time of monitoring. And when we see that there is this sheer decrease in the performance, then what we do is like we trigger we can think like we can actually trigger a sort of a button that will actually restart the model training for those new sets of data, right? So for that, it is very much important to actually create an end-to-end pipeline where we can ensure this model retraining as well as deploying the model, packaging the model, as well as that is developing this whole pipeline. So it's like I have to package it, I have to deploy it, I have to retrain the other pipelines and everything. So this is my second step. My third step is actually mainly for the production step, for the mainly inference, where we have to actually set up an inference server, and we have to create an environment in such a way that our machine learning model can actually talk to the backend, and at the same time, vice versa. And at the finally, it is very much important to create some additional that is pipelines for the model, which actually includes the other data pipelines and also the model monitoring pipelines, as mentioned before. Next, so now it is very much important to to actually see that if we actually go over the whole life cycles and like discuss everything one by one, then I guess the most of the like today's session will go on that part only. So let's just jump on the why we actually need containers in particular or in specific for all of those things. So now, now we actually didn't. The use of containerizations has been actually been skyrocketed like in all of these years, and there is like some of the main reasons, and the main reasons actually include like the very first thing is like consistency. Where okay, so now another thing that if you guys are not very much familiar with containers, then for now I will also go through like what a container is, but for now, you can think like container is simply just a container or a box. You can just think of it a cardboard box where your software has been running up. So this is what you can think a container for now. And why a container is very much important in all of those practices is because the very first thing is like it actually provides me consistency. Now, what do I mean by consistency? It's like, for example, I have built a machine learning model which is running on Windows, right? I started out with Windows, and suppose if I have like given or for example, if I like push this code to GitHub and another person actually comes and like installs it from that clones it from GitHub and tries to install the dependencies, there is a very high chance that there can be a dependency clash or there can be some loss of any dependencies or anything, and it actually creates a lot of mess, and a great amount of time is actually spent on how we actually like we on actually recreating the whole dependencies and reproducing the whole model results from scratch. So in order to avoid those, in order to establish the consistency from one platform to another platforms or from different environments, the containers actually helps a lot in this manner. Second thing is isolation. It's something, suppose my main host system is having, suppose is running on is having Python 3.9, but the container which I am using has been isolated from my host. So this is my host and this is my container. And this might actually run, suppose Python 3.8 or Python 3.6 or so on, and suppose some any other dependencies, like for example I have a lot of packages in my Ubuntu, and those packages might have different versions than the one which I'm actually using in the container. Even the operating system environment which I'm using is actually been isolated with my host. So on top of everything, so what's the main like point of actually having this isolation is just that there is no such clash of dependencies when we are actually running the software inside that container, right? Because it's not affecting the host, and the host is also not affecting the software when it's actually running. So that's the main that is point of having the isolation. And second thing is like portability. Now, why portability? If you think of the container, as I mentioned, that we can think that container is just a simple cardboard box, then all you can think like I can actually like take this box from one place and then like push it, or it's like just take it to some another place and what the place means, the place here means, for example, which environment you're using. You might be using a development environment, then you push this thing to a production environment. So you can do the changes within the container or if you are required, and without any sort of further, like for example workload. The that is the movement or the using the portability of moving the container from one environment to another is like super easy. It's just like pulling the images and just running the building a container from that image. Next is scalability. Now you can think of, like for example, think of this is my container is something like this, which is actually in a server inside a VM. And suppose I am this is my, suppose the user base. So this is completely different from the servers. So now users are actually suppose requesting for some sort of model predictions through their some of their data through some sort of API. Let us assume. Now I will also explain what API is, but suppose for now the user is requesting some sort of prediction. Maybe, for example, what I can say, something, some sort of recommendations of something. Now we know that in like any popular social media platform, we do not have 100 users, right? Or 1,000 users. The scale is in millions and billions, right? And if you think, then it is actually not possible for one server or one container to manage all of the requests. So in order to produce very fast, have the very fast response with very low latency, we have to actually distribute the whole thing, and we have to actually balance out the loads between different entities. What I mean now from is, like, suppose suddenly my user has some sort of rise from, suppose, 1,000. Suppose initially I have 1,000 users and my container was able to manage all the requests and provide a very good and fast response out of it. But now suppose my user that suddenly changed from 1,000 to 10K, then what I can actually can do from different sort of services, which I through the containers, is like I can create replicas of different containers, something like this and this and this and a lot of replicas. And now my load is been distributed among all of those containers, which you can think of as a load balancing. And once we are done with this, then easily I can actually provide the same sort of experience to not only 10,000 users, but how much it will come, we can actually provide. We can like potentially provide the same sort of experience. So that's the reason thing of scalability. Next is the cost effectiveness. Now, it is very much important. For example, containers actually use very optimal amount of resources, which is as much it is actually required, right? It doesn't, if it doesn't require the, and it also can scale itself up based on the amount of resources it needs. So because of this optimizations, for the organizations or for the startups or for any projects which is actually starting up, we do not need to spend some extra amounts for resources or for any of the other services if we have this sort of environment or thing. So that's the main reasons of actually using containerizations for actually the modern machine learning, not only for machine learning, but also for example, for any application development, that is workflows. Now, how it is actually but in all of the, for example, for all of this 15 minutes, I have actually not talked about machine learning at any point. Then why I do require, then any thoughts on how this is actually been used in machine learning? So if I cover it up, then you can think, like, for example, my you can think of, like, in machine learning, that is the in the overall, like, the life cycle or a workflow, there is not a very any single entities which is actually been present. There are like lot of services, right? For example, there is, suppose this is my service one, which is handling the data. Suppose this is my model one, which is actually doing some sort of intermediate predictions. Suppose this is my model two, which is doing another intermediate predictions, where the model one's predictions with some data is fed for model two, let us assume. Then in order to make all of these entities independent, work independently each other and communicate freely, we use containers and treat all of those as an independent entities. And we treat like this. Now my this service of data service actually communicates over my models. My models then actually put some response to model two when model two request to model one, as well as it also communicates with the data. And all of these things can be achieved by creating the APIs on the top of it. But when we are actually going to starting out to actually deploy those APIs in production, then using containerizations actually makes all of those stuffs much easier and easily maintainable for all of the reasons that I've stated above, like consistency, isolation, portability, scalability, cost effectiveness, etc. So I hope you get the sense of the why we are requiring to actually use it. Now, any questions before we move ahead? Any questions? Should I move ahead?
Yeah, Anil.
Yeah. Any
So,
questions?
yeah, like what's the difference between using environment like virtual environments and Dockers?
So now the thing is, like, if you, that's a very good questions actually. So if you think virtual environments, specifically if we take about Pythons, then it also acts like it also acts like a service which can actually isolate the dependencies. But if you see, then it's actually specific to Python. But now if you assume that, suppose you are creating any sort of applications which was running on Windows, but it
Mm.
might not run on Docker because it might have some dependency which is not in Python, but it has some system dependencies on Windows. Then what you will do in that case, right? So suppose
Okay.
it's not only about Pythons. There can be other dependencies. Like if you have run Ubuntu, then there have some other packages in Ubuntu, right? There are like a lot of Debian packages and everything. So now suppose your application is using all of those packages in some ways, and now you are installing your like systems or your application to some, suppose, Arch Linux, then they do not have the same sort of thing, like same sort of dependencies, right? The packages in Arch are different in the packages in Ubuntu. So what I try to do is I try to create a container of Ubuntu and then ship it to anywhere such that I can also use the same in my Arch. So that's actually a difference in Docker, that Docker actually extends this whole thing, whereas you cannot extend or like scale on the basis of all of that using the only sole virtual environments, right?
Yeah.
So yeah, we can think of it like that.
Yeah, thanks.
Any questions more, or should I go further?
Yeah, Ananda, I had one question which I posted in the chat. Do you want to take it now?
What factors should be taken in account while deciding between real-time inferencing and batch inferencing? I hope, I guess I will take it for later because it might get deflect to the topics which are actually in consideration. It's actually
Sure.
falling into the MLOps. So yeah,
Awesome. Awesome.
but
Thank you. Yep.
okay. I will take this to account. Next, let's go to deep diving to containers because that's a very important part while learning all of this. So what are containers? So if you think about containers, as I mentioned before, you can just think of it's simply a cardboard box where you just suppose so suppose initially I have this empty cardboard box, and now what I try to do is like first I try to put some OS in it. Then suppose I put some sort of dependencies to it, for example, any drivers or any sort of thing which is required. And then what I do is like, so there are my dependencies, and where it from where I'm taking it, and also like, for example, this is my OS. Next, what I'm trying to do is like I'm copying all my stuff from my host. Now suppose this is my host, or this is my actual local system. I'm copying all of my project files and I'm putting this to the same cardboard box. Once everything is done and I've given my specific instruction to my box to how to run it, then what I do is like I seal the box, and now it is actually ready to actually ship or run. And from now I can actually give this box to any of my friend and they can actually run on their devices. So this is actually how you can think about containers. You might have also think about also like learn about Docker, but if you are very much I don't know this is a thing that most folks, even I was also much not aware of. Docker is not a container, and it is very much important in concern because the Docker is actually a platform that actually provides the services of creating, managing, and deploying the containers or the images. But Docker is in specific is not a container. There are a lot of services which actually provides creating of containers. And if we think about what containers are like formally are, because this is not the formal definitions, but all we can think is like containers is just some sort of an executables which are like very lightweight, and all it does is like it actually, and those executables are actually very much configurable and customizable based on the dependencies that we put on the top of it. And it is actually mainly used to run, ship some particular applications or software. Now if we go over it, like how I then create a container. So or for example, once I had, now what happens like when I actually start a container, then it is nothing but all it does is like, suppose this is my host system, and in my host system, now just think of like I have an image which is taken from my which is taken from any sort of Hub. You have heard about Docker Hub. I will also explain what an image is. But just think, image is this blueprint of actually what a container is. You can actually think of like a class and an objects thing. Like you can actually create multiple objects by instantiating a class out of from it. So all you can now think is like you have taken the image, or you can think that you are importing a class from somewhere, and then you are instantiating that class to some another place. Now do not also think that the class Docker is my that is image are my classes. It's just the way to actually have an analogy, but both are different. So now think that I have taken this image, and when I try to run the image, then what it will do is like it will actually allocate some specific amount of resources and volumes from my host, and then it will actually build all of those executables and binaries which we have actually mentioned and specified while building the images. And it will do according to the instructions that we have actually put initially. So the instructions actually looks like this. Like we have actually, suppose this is my instruction file, and this instruction file is in Docker. We can actually tell it as a Docker file. And what it does is like, for example, we have told like, okay, first you have to actually take the base image, or you have to build an operating system out of it. And then what you have to do is like, suppose you have to fetch or you have to actually pull Ubuntu as an operating system and build it there. And then you have to actually run some sort of dependencies, for example, run some sort of depend like app packages on it, like run some app packages, and then install some Python libraries. Also, I also told like initially I have told that copy from my local machines to the Docker containers, which the Docker container which will be actually be producing after building it from image. So it has some existing files which it has to run. And finally, I have also given the instruction that okay, finally what it will do is run that main.py. So once this image will be creating, it will actually pull the base image. And then what it will now, what the base image is like, for example, as I've told that in the Docker file, so you can think something like this. Let's go to this thing. So this is actually an initial Docker file. So what it does is like, this is my base image. Now, what does a base image means? It means like the operating system, the bare minimum requirement of an OS, because all of my apps and services will be actually required an operating system environment on which it will actually run on, right? So it will have this. So it will pull. You can think of it as you are pulling or building an operating system as your base platform, and then on the top of it, what you do is like you actually run some sort of an add packages. I guess you are like familiar with like what an add packages. You can just think of it some sort of dependencies, right? Then what you will do is like then you will like install some sort of Python dependencies, like for example NumPy, Pandas, Matplotlib, TensorFlow, PyTorch, etc., etc. Once done, then you are telling like, okay, these are my all the project files and everything that you all need to run. So copy all of these from my local host, from my local to yours. So it will copy all of those stuff. It is, and this is actually been done during the time I'm actually building the image. When I am actually building the image. It's not during the time when the container is been running. It's all happening and in a very compressed manner when the image has been built. So when I'm just building on the image, I'm now I actually run all my dependencies. I've copied the thing, and finally I have told it like, okay, so finally it will just run the main.py or the train.py file, and yeah, your job is done. So what it does is like after each and every instructions, which is it's actually following step by step, like this is my first step, second step, and third step. And you can also probably see that why I have actually used all of these like this layers on layers. So what Docker actually does is like it actually builds all the like instructions as layers, and it also keeps an hash of which is a very unique identity for each of the layers. So you can think of like I have created a base platform, and on the top of it I will create my new like changes on that platform. So now you suppose for example I will need a new app packages, or suppose I have installed like joblib, but now I also need, suppose I did run pip install TensorFlow. So what it will do is it will first check like, okay, now this is my something new instruction that I've got. So I have to create a new, that is, I have to build a new, that is layers on the top of it. So till this, everything will remain same. And this has been the main sole reason for which it has been done, is because to manage the time. Because every time I will not take or pull the base images or build from Ubuntu and run all of these packages, right? Because there are packages which are like, suppose 1 GB, 2 GBs, like these are so much large. So I cannot build everything from scratch every time. So if I have this sort of, if I track that how much it has been already done and which new things are already been introduced, then I can only install the the newly like introduced things to my existing image, and then I can build on the top of it. So that's the main reason how a Docker image has been built. Now this image is actually creates or now you can think that, okay, my main entity or my precursor of the container has been already been built. Now what I can do is now I can ship this executable, and I can like, for example, push it or deploy it to any of the environments as far as my requirement. And one way is like you actually do this registry of the images to a hub. One good example is like Docker Hub. What Docker Hub does is like it actually saves, or it's actually stores your images, and it actually gives some specific tags based on the changes you are doing. Like for every changes, it actually maintains a version around it, and people pull all of those images. Now what does pulling means? It's simply like, suppose you are cloning a GitHub project of some version and you're running it or building on the top of it. Similarly, the Docker pulling a Docker image is like you're pulling the or downloading the Docker images, and you are like creating a container out of it. So that's, as a very like, so that's how it's actually that we build the Docker images from Docker files, and we also like build the Docker containers out of it. I hope like the now there are like a lot of stuff of when we actually like tell about the Dockers or containers in general. Yeah, there is a huge thing to cover, but as the sessions are 1 hour long, so I guess I will not go too much deeper. Let's take some questions. If the questions are like longer for answering, then I will take it for last for the Q&A. Are you good? Okay, this is a thing that I will go after during the time of Q&A. Anything else? Or should I mean, I just wanted to know if this thing is being covered. You can also push and pull containers itself and hubs called, yes. In specific to Docker, it was like the Docker hub, but there are services of container registries where we can actually push and pull the containers itself from the hubs. So yes, that's a good point, Anish. Anything else, or should I move forward? Okay, I guess I will move forward. Okay, so now how I will use those containers or the images that have been built, right? I mean, I need a way so that these things that like these fancy things that you're actually hearing, if you're new to it right now, then I have to use it in some way. I need to use it in some way, or which is already been, which are already existing, right? So one way you can think of it is like is the APIs. So what the APIs are, this is, if you just go through formally, then it's just application programming interfaces, but it doesn't make any sense if I just go through that. All you can think is like, suppose you are a user and this is my
திக்கா கடை
server,
திறந்து இருக்குமா?
and just specifically if I go through the right term, then you are a client. And what I do is this is a very standard and classical like client server model, where a client is actually having or like requesting something, which is a request. It can be any type of request. It can be a GET request. It can be a POST request. It can be a PUT request, anything which is related to my CRUD operations. And I get some sort of response out of the server. for the same, right? So based on the request the client has been put. So if you think, then APIs is actually has been working on like on
Huh?
this workflow where I will be having a client. The API will actually listen
Adesso qua.
and to the
Ah,
clients, and based on the like the request I'm getting, the
ah.
API will work accordingly based on
For
the
the
endpoint it has been
explanations
assigned
that
to,
transit.
and it will try to generate
Avada,
some
David
specific
Ditz.
response, and it will be giving back to the client. Now, where and how Docker actually comes into the play? So if you think carefully, then there are like a lot of services. For example, now let's just like assume the scenario, right? Like suppose you are you are creating a web applications, right? And in the web applications, suppose initially this is like initially suppose you have, let's okay, I will be actually showing my like repository for the same. So let's just open the terminal here and code. Yeah. Now what I wanted to show you here right now is this, the file structure. Now, if you see it properly, then this file structure is like a lot. I mean, there are a lot of files, lot of folders, and you can see that in one place only I have this app, I have this data, I have this models, I have this notebooks, I have even the saved models, even I have like a lot of things right there, right? And if you think like this is actually a web application that actually classifies some sort of yoga poses, which is like very simple. But if you think it properly, then right now, how I actually got started was a monolithic way. And what does it mean is like everything, like each and everything, for example, my database, my app, which is my suppose the website application, my Streamlit app, anything, my models, my machine learning like inference engine, everything has been in one single place, right? Now there is a lot of problems. Like suppose if everything stays in one single place, and if I have to actually scale everything, then what I actually have to do is like I have to scale the backend also. But I do not need to scale the backend if there is no requirement, right? Like suppose my backend is okay, it is actually like it's working fine, but my ML model is actually not able to take all the requests at the same time, right? So during that time, I need to actually scale my ML applications, or my that is my ML inference engine, which is having the machine learning models, not the backend. Or if it's having an existing front end, then I do not need to like scale up the front end. Or if there is an existing database, then I do not need to scale the database. So from this transition of this monolithic way of everything having at once, like this is my front end, this is my back end, this is my database, this is my ML applications or ML inference engine or anything which actually does the inference. And suppose there is my another pipeline which does my ML training. Everything is at one place, and suppose you want to like scale everything, then all you have to do is like you have to create a lot like similar sort of like duplicates every time, and now you are actually scaling it. But if you think, then you are actually like wasting a lot of resources, right? And also it's not cost effective. But suppose now what you have is like you have a front end like this, you have a back end, you have the database, you have the machine learning inference engine, and everything is scattered around here and there. Okay, just one thing. Let's make it something like this so that it's better. Yeah. Okay. So now suppose, and now if you think, you can just think that each and everything are actually as a container. And for example, front end is I have built a Docker image which will only run my React app, and backend is something which will actually run my Node applications. And suppose my let's assume on it, I'm not like very much stressing out on the main technical terms on how and why we are like running a React app or Node app as a backend or anything. you can also assume that I'm like running Flask applications as the backend. Okay, I guess yeah, we can hear. Yeah, we can run the Flask applications as backend. So suppose I have a Python backend, and also I'm having this ML inference engine, which is also like another thing. Now all of these will actually like communicate with each other through like API requests. So what it will do is like front end will actually ask for, suppose a user has logged in. So for logging in, suppose I'm showing a sort of a dashboard. So front end will actually render its HTML through some sort of an API request, which is based on once the user is authorized, and backend will actually put some response to it. Similarly, when the users triggers something for suppose for the model's prediction, then it's actually done from the front end. Front end actually either sends the request to the backend, and then backend actually like maybe it actually does some like do some operations on the top of that response and then put towards the front end. So all of these are now actually managed, and all the communications from one services to another services is actually managed through different sort of API requests. And now that if you think that if my ML applications is having a greater load or a more load, then what I can do is that I can just scale up only my ML application. I do not need to like scale up my front end or back end at the same time. So, and even for example, if suppose this ML this container is actually or this part is not working, then I can actually spin up another container so that it can just take the place of it. So the capacity or the extensibility of getting healed is also very much efficient when we are having this type of like whole workflow around it. So here actually comes this concept of creating like cloud native machine learning applications, which is which is very much which are actually getting very much like popular nowadays. And it is also because of the terms of what the main reason is, because the way that it we are like the way fast we can actually deploy it, the fast we can actually scale it, then we can actually heal it if required. Like for example, if any existing containers like shuts down for any sort of reasons, then I can also like spin up another container within minutes or within seconds, and actually that can takes the place of my existing containers, and we can repeat the whole steps. So that's how the cloud native applications has been built around it. And ML applications are not something new, so those are also now like joining the whole team. So if you so there's this another thing actually that I forgot to mention, that the communications between all of those like containers could be actually be done. And you can actually think of it something like this. Like if you go to this Docker file and suppose you are running a Flask application, then what you will do is just like instead of train.py, you will do like suppose my app.py. And also you will also give an instructions that okay, I want to expose a port of yours. So what it actually I need to like explain this thing. So I already like
Yeah, Anit,
mentioned like Docker contain. Yeah,
we have only 12 minutes left.
yeah, sure.
Okay,
I mean, it is finished actually. So
okay.
the thing is like the Docker containers are actually already been isolated, right? So as they're isolated, so one like cons of it is actually that if you send any sort of request, then it will not take any sort of request because its scope is around this container only. But suppose I need my container to like talk with other like my other system, like to the my other side of the world, then what I need to do is I actually export the port on which the Docker container is running, such that I can actually such that after the exposure is done, then now my Docker containers can like freely communicate with each other. And once this is done, then you can actually think of it as like I have like as I deployed the Flask applications, I've created a fast API around my ML inference engine such that I can provide my inferences of different types of inferences as some sort of response to some endpoints. So all of these now could be easily be done, and I can create this whole communication network with ease. And this thing of like auto scaling, auto deployment, self healing, and repeating the whole steps and getting like orchestrated about all of these things is been done by a lot of like great services, and one good services is actually Kubernetes. I guess you have all heard about it. And also with specific to, for example, machine learnings like inference, monitoring, and orchestrations and the other things, Kubeflow is another thing which actually does this thing more easier, like for example model retraining and everything about these on this CI/CD pipelines, like this continuous integrations of different models and services, and also the continuous step, that is the deployment, and everything can be managed using Kubeflow. And Kubeflow is actually like based on the backend of Kubernetes. So that's how the modern machine learning applications and services are actually been running, and it's getting very fast developed. And that's the reason why you can actually see like the way when a new, for example, concept gets appeared in a research paper or so, or in research, then you can see that within some days only, it's not about months, within some days a new organization or startup is being created. And one very good example is that is Stable Diffusion, right? Stability AI has come like very fast once the Stable Diffusion has been emerged. So in order to create all of these things, these are actually one of the ways to go to create very fast and robust machine learning applications. And finally, one thing I also have to say here, that it's not only once if I have told that like cloud native applications are like really great for all of these reasons, but that doesn't mean that cloud native is the only way to go in order to create machine learning applications. You can also create ML applications without like using containers, and there are, and also not like for example orchestrating or like creating microservices around it. You can create a single monolithic applications also, and sometimes it is better than just creating like microservices around it. Like if I missed, then all of these are actually acting as an independent service. So we are saying about a microservices. So all of these are microservices, but sometimes monolithic applications are actually better. And one good example is like when you're actually gaming and streaming, then that time it actually acts better. We can actually talk about it in other sessions. So for now, if we like jot down everything that what we have learned, then we have learned and we actually went over our production grade. We actually saw a glimpse of how a production grade ML lifecycle looks like. We got introduced to containers, we got introduced to Docker, how to create a Docker file, how to build an image, and like how to run the containers. And also we also saw that how containerization is actually used in terms of API development, and also a small like glimpse of the cloud native ML applications. So yes, that's the whole thing. Even I will actually share the slides, and also we have some good resources on how actually to go there. Even I'm also actually got started out with this this whole thing of developing machine learning applications on the top of like machine learning models just like some times ago, and it's like around 3 to 4 months. But the learning experience has been great, and today's session was mainly around like sharing my learning experience of how far I have learned. And also in the coming sessions, I will actually also try to have some hands-on where we will actually create a fast API, which is that is a REST API for our ML models, and try to like containerize it using Docker and try to deploy it in Docker Hub. So that's the thing. So stay tuned for that. And I guess we can go forward for Q&A, and also stay tuned for the next upcoming sessions of Nikunj, where he will also that is give a presentations or take the sessions for ML Ops. So yeah, that's all about it. I hope I could make able to understand some of the things that I've actually learned in the recent days. Yeah, thank you very much. Any Q&As? We have another like 7 to 8 minutes. Any more questions, or we can actually wrap up the sessions? I will let us share the slides, and also I will also try to create a blog around it and publish to our Cord AI's like new, that is the newsletter, and you can actually access it from there also. So yeah, any further questions? Okay. Well, yeah, there was one question of Behance, and that was like, how do you get started with about ML ops and containerizations? do you have any documentation? So okay, so I guess I actually have answered the questions. In you can actually find very good like resources on that is the in the slides only when I'll be sharing on the that is the page where I have mentioned about Dockers and containers. In just in the below you will be having the corresponding resources that I followed, and also in specifically to where to go from here sections. The last the link that I've actually shared will be this Made with ML, and this is an amazing resource in order to like start everything. If we do not if like folks not like if folks are actually starting out. So yeah, that's my personal favorite now. Yeah, and another thing is account real time. Okay, now what factors should be taken in account while deciding? Yeah, I will share the slides just after the sessions in the AI communities like channel as well as on Twitter. And yeah, the factors. Now, this is actually a very good question, Anish, and I might be very much not sure about it. But the thing is, like, what I have learned till now is the real time inferencing is only been required when you're actually like when we are actually required to provide like within on time responses. Like, for example, suppose you are working on some frames of images and you are putting into some ML models, and if you want to require some direct response from it, then yes, we can go for our real-time inferencing. Otherwise, batch inferencing is something that, okay, we can actually sacrifice a bit on time, but we can actually give more that is focus for the throughput, which is we can give a more amount of responses in a bulk as a bulk. Then that time batch inferencing actually works better. Yeah.
Yep. I think that makes a lot of sense. Yeah, that's what I was looking for as well. Thanks, Anindya.
Yes. Okay, so I guess we are now running out of time. So yeah, that's all about the session. And also stay tuned for the hands-on.